Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have this is c square root of c minus 3 divided by c minus 3 is equals to 3, and we solve this problem for all the values of c. So I hope so you like this method, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And here we you know about that if we have a number that is a, so we write it as square root of a multiplied by square root of a. According to this rule of radicals, we write the c minus 3 as, in the same pattern we write c minus 3 as square root of c minus 3 multiplied by square root of c minus 3. So we replace this value in this case so that our given question statement is written as in this form. This is square root of c minus 3 divided by square root of c minus 3 multiplied by square root of c minus 3, and this whole equation is equals to 3 only. And further in the next step we have this is c minus 3, and this c minus 3 are cancelled out by each other, and we get the remaining values are 1 divided by square root of c minus 3, and this whole equation is equals to 3. And further in the next step our target is to find the values of c. So for this we move this c minus 3 square root to the right hand side, and it will be written as 1 equals to 3 times of square root of c minus 3. And now further in the next step we need to remove this square root sign, and for this we apply squaring on both of the sides. And you very well know about that the square root of 1 becomes 1, and here we apply square separately on both of these two values, and it will becomes 3 square into square root of c minus 3 and its whole square. And further we have 3 square becomes 9, this 2 and this square root are gone, and we get here c minus 3, and in the left hand side we have only 1. And now in the next step we multiply this 9 separately on both of these two values, and it will be written as 9 times of c minus 9 times of 3 becomes here 27. So we move minus 27 into the left hand side, and it will becomes 1 plus 27 equals to 9 times of c. And further we have 1 plus 27 becomes 28 equals to 9 times of c. And further we need to divide both of the sides by 9 in order to find the values of c. So that we divide both of the sides by 9, and this will becomes here this 9 and this 9 are gone, and we will just get only one value of c, and that is equals to 28 divided by 9. And in the next step we need to verify that is this value of m be the solution, or is this value of m be the extraneous root. So for this we need to copy down given question statement here, so that our given question statement is for verification case we just copy down question statement here. It is square root of c minus 3 divided by c minus 3 is equals to 3. So this is our given question statement, and here in this case we just substitute the value of c is equals to 28 over 9 into the left hand side, and we check its behavior. So when we put it here it will becomes 28 over 9 minus 3 square root divided by 28 over 9 minus 3 is equals to 3 or not. This is the our claim. So here when we take the LCM of the numerator term, it will becomes here so the LCM of this term becomes 9, and we get here 28 minus 9 times 3 becomes 27. And in the same pattern we also take the LCM of the denominator term, and its LCM becomes here 9, and we get here 28 minus 27, and we check that is this equals to 3 or not. So here we just simplify the term, then we have 28 minus 27 becomes here 1, and we know that the square root of 9 becomes here 3. So you see that here we have the fraction, our fraction, so that we move the fraction from denominator to the numerator, and we just have reciprocal this fraction, and we write it as this is 9 divided by 28 minus 27 is also becomes here 1, and this is equals to 3. And further you see that this is 3 times 3 becomes here 9, and finally we have 3 is equals to 3. This shows that the value c is equals to 28 over 9 is satisfied our given question statement, and this is our final answer of this question. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.